Good day everyone. For today's lesson, we will discuss about Introduction to EM waves. Our most essential learning competencies is to compare the relative wavelengths of the different forms of electromagnetic waves.
There are two important waves on how energy is transported in the world around us. We have mechanical waves and electromagnetic waves.
What are the difference between mechanical waves and electromagnetic waves? Examples of mechanical waves are waves in water and sound waves in air. Matter such as solid, liquid, gas, or plasma that mechanical waves are traveling through is called a medium. While on the other hand, electromagnetic waves such as visible light differ from mechanical waves in that they do not require a medium to propagate. This means that electromagnetic waves can travel not only through air and solid materials, but also through vacuum space.
How EM waves form? Electromagnetic waves are formed when an electric field comes in contact with magnetic field. Electricity and magnetism can be static. Changing magnetic field will induces electric field and vice versa. These changing fields form electromagnetic waves.
Keep in mind that electric field and magnetic field of an electromagnetic wave are perpendicular to each other. Remember, also the electric field and magnetic field of an electromagnetic wave are also perpendicular to the direction of the EM wave. An EM wave travels with a constant velocity or speed of 3 times 10 to the power of 8 meters per second in a vacuum space.
Waves are deflected neither by the electric field nor by the magnetic field. However, they are capable of showing diffraction. EM waves are transverse waves. For you to understand the behavior of EM waves, here we have the characteristics of a wave. Amplitude, which is the height of a wave, and usually measured in meters. The greater the amplitude of a wave, the more energy it's carrying. Another characteristics of a wave is wavelengths, which is the distance between two consecutive troughs and measured in meters. Next is frequency, the number of waves passing a point in a certain time. We normally use time of 1 second, so this gives frequency the unit hertz, since 1 hertz is equal to 1 wave per second.
Every single second, you feel the energy transferred by EM waves. The electromagnetic spectrum describes a wide range of different EM waves, which include different frequencies and wavelengths.
There are different types of EM waves. We have radio waves, microwaves, infrared, visible light, ultraviolet, and gamma rays.
This is known as electromagnetic spectrum.
Examine the electromagnetic chart, starting from radio waves to gamma rays. Compare the frequency and wavelength of M waves. As you move from left to right, the wavelength gets smaller, and frequencies gets higher. There is an inverse relationship between wavelength and frequency, which simply means as one goes up, the others goes down. If energy goes up as the frequency increases, the energy is directly proportional to the frequency.
Example: radio waves have low energies, microwave have a little more energy than radio waves. Infrared has still more energies. Likewise, with the order of colors of visible light, they are ranged from lowest to highest frequency. Red has the lowest energy and frequency, while violet has the highest energy and frequency. Lastly, we have the highest frequency, but has the shortest wavelength, the gamma rays.
EM waves can be classified as ionizing or non-ionizing from radiation. Radiation is the part of electromagnetic spectrum where there is insufficient energy to cause ionization. This includes radio waves, microwaves, infrared, visible light, and ultraviolet. While in ionizing radiation, this type of energy released by atom that travels in the form of electromagnetic waves. This includes X-ray and gamma rays.
Did you know that ionizing EM waves are more dangerous to humans than non-ionizing? Keep in mind that electromagnetic spectrum is continuum of all electromagnetic waves are arranged according to frequency and wavelength.
To summarize what we have learned,
I hope you learned something new in this video. Bye! Thanks for watching!
the electromagnetic
Asimo problems.
Isin mo na ano.